Now let's look at the sum of a geometric series. So here I have a series, my first term a, second term ar, ar squared, ar cubed, all the way to ar to the n minus 1. So this series has n terms, and we want to find the sum of all those n terms. That's this s for sum, n for n terms, and since a, my first term is a with no r, I end up with r to the power of n minus 1 and terms in total. So to do this, we are going to use a little trick to help us work out the sum. What I'm going to do is multiply both sides by r. So if I did that, I would get r in front of Sn equals, and then I would have ar plus ar squared plus ar cubed plus ar to the fourth plus, I might just write the previous term, ar to the n. Remember, we're multiplying by r, so if I take this term, multiply it by r, I have r to the power of n minus 1 times r to the 1. You add the two powers, it becomes r to the power of n. So just by using our index rules. Alright, now there are two things we can do. We can either take the first line away from the second line, or we can take the second line away from the first line. So we're going to do both of them. Let's do 2 take away 1. So on the left hand side, I would have r Sn minus Sn, and on the right hand side I would have ar minus a plus ar squared. So I'll just highlight what I'm doing, ar, then we have a minus because we're starting with line 2 and taking away line 1, minus a, and then plus ar squared. It will be minus ar, and then plus ar cubed, minus ar squared, plus, and so on. Another way of doing it, which might make it a little bit easier to see, is if I just write the second line down. I might leave this. The second line minus the top line, and that minus gets multiplied by every term inside the bracket. But this way, the way I've written it above, you can see that this ar will cancel with this ar squared will cancel with ar squared. I hope you can see that ar cubed will cancel with ar cubed. If I was to keep going, I will have ar to the n minus 1 minus ar to the n minus 1 plus ar to the n. So every term in between cancels, and all I'm left with is that first and the last term. So let's clean this up. I can take a factor of Sn from the left hand side, that's r minus 1, and I can rewrite with ar to the n at the front, so I have my minus coming afterwards, and I can now divide both sides by r minus 1. Take a factor of a out, r to the n minus 1 all over r minus 1. So that's one of our formulae. That's one possible option. As I said, the alternative is to do 1 take away 2. So now we're going to take equation 2 away from equation 1. So on the left hand side, I am going to have Sn minus Rsn, and on the right hand side it's A minus AR plus AR minus AR squared plus AR squared minus AR cubed, and so on. And we'll finish with AR to the n minus 1 minus AR to the n. So just like before, you can see that these middle terms are going to cancel, and I'm left with just the first and the last term. Take a factor of Sn out, 1 minus R. Take a factor of A out, 1 minus R to the n, and Sn is going to be A 1 minus R to the n all over 1 minus R. So I ended up with 2 equations, and we use both of them depending on our ratio. So if our ratio lies between 1 and -1, so we have a fraction ratio which is less than 1 but greater than -1, so 0.5, -0.25, things like that. Then I use the formula where in the denominator I have 1 minus R, and how I remember this is if I'm taking away a small value, if my ratio is a small value, then I have to take it away from 1. You can come up with your own way of remembering. Actually, as a matter of fact, now these formula are given on your reference sheet, so you really don't have to memorize them. Except on the reference sheet, they represent this as absolute value of R less than 1. Which means the other case is when R is less than -1 or R is greater than 1, and on the reference sheet they'll represent that by absolute value of R greater than 1. We don't have to worry about R equaling to 1, because when the ratio is 1, you're going to end up with A, and so on, or going from positive A to negative A, positive A to negative A, which is not usually the type of series we're interested in. So these are our 2 formulae for sum of a geometric series.